Hello everyone, Mr.Drover here, and welcome back to another lesson. Today we'll be looking at potential and kinetic energy. The first thing we'll look at is gravitational potential energy. Gravitational potential energy, or GPE, is the energy stored in an object when it is lifted above the Earth's surface. Meaning that when I lift something upwards against gravity, it gains potential energy. The formula we use for potential energy looks like this. E with the subscript P equals mgh, where m equals mass in kilograms, g equals acceleration due to gravity, which is 9.81 meters per second squared, h equals the height in meters. Here, let's look at an example of where understanding gravitational potential energy could possibly be life-saving. Say you are lost hiking through the desert mountains. After a while of trying to figure out where you are, you notice that you can get back down to where you started if you just jump directly downwards from where you currently are. Jumping down now would save you time and guarantee you wouldn't get lost again. But the cliff is quite high. You think back to that Captain America movie you watched. He did something similar and he was fine, and you're pretty darn athletic yourself. But just to be safe, you decide to do the math in your head to determine how much potential energy you currently have. If the amount of energy seems high, you'll refrain from jumping and take the long way down. So, your mass is approximately 63 kilograms, the cliff you're about to jump off of is 450 meters high, you know the acceleration of gravity is 9.81 meters per second squared, you know that the gravitational potential energy formula is mass times acceleration times distance. So in this case, it would be 63 kilograms times 9.81 meters per second squared times 450 meters. This gives you on a cliff a potential energy of 278,113.5 joules, or using scientific notation, 2.8 times 10 to the power of 5 joules. Now, you realize this is way too much energy for your legs to absorb, so you decide to take the long way down. But, just for fun, let's see what would have happened if you decided to jump down. Oh, the example's done already. Sorry, I was just cooking up some eggs. I didn't eat breakfast and I need my protein. What I like on my eggs, I like some pepper. Alright? But I also like some salt. Okay, you know what I'm saying? Salt's really good for you. Oh, no. Oh, sorry about that. Well, at least you got to see what happens when potential energy is released. Now, the funny thing is that the work that it took me to grab the salt shaker from the ground and put it back to the same height that I dropped it at is the exact same amount of energy as the salt shaker's potential energy. So the neat thing is, if I knew how much energy it takes to lift the salt shaker, I also know its potential energy if it's just suspended at that same height. This is because work and potential energy are equal to one another. They share the same units. The cool thing about this is that you only need to calculate one of these things to get both of them. So if I were to calculate the potential energy the salt shaker has right here at this height, it would be the exact same as if I was calculating work for picking it up. So this salt shaker is 0.45 kilograms, almost exactly 1 pound if we're talking imperial. Now we know the acceleration of Earth's gravity is 9.81 meters per second squared, and we know the distance here is approximately 1 meter. So we just plug those right into our formula. We go 0.45 times 9.81 meters per second square times 1 meter. Then we'll get an answer of 4.41 joules. Now it takes 4.41 joules to lift it up. It also has 4.41 joules of potential energy stored. So if I dropped it, and it hit my head, I get hit in the head with 4.41 joules. That's a cool example that happened out of a seemingly random occurrence. Let's get back to the set. Where were we? Oh yes, kinetic energy. The next form of energy we are going to look at is kinetic energy. In this equation, kinetic energy equals 1/2 mass times speed squared. Remember, the units for mass is in kilograms, and the units for speed are in meters per second. Here, let's use this example to calculate potential energy. A skier has a mass of 79 kilograms and is moving at a speed of 12.3 meters per second. What is his kinetic energy? So, like everything, let's plug in the variables into the formula. Kinetic energy equals 1/2 times 79 kilograms times 12.3 meters per second squared. Now, it is important to remember your order of operations for this. We start by squaring 12.3 to get 151.29. Then we multiply the number by 79 to get 11,951.91. Finally, we multiply that number by 0.5 or divide it by 2, whatever floats your boat. Anyway, we end up with a final answer of 5,975.955 joules. And remember, we must use scientific notation to have a complete answer, or the best answer. Looking at our variables, the lowest amount of significant digits we had in our variables was 2. So we need to trim our final answer to 2 digits and have it between 1 and 9. So we move the decimal place over to the left until we have a number between 1 and 9. In this case, we move it over 3 times. Then we round the answer. Then we add the times 10 to the power of 3. Remember, we use 3 as the exponent because we moved the decimals 3 spots to the left. So our final answer would look like this: 6.0 times 10 to the power of 3. Now remember, you can rearrange this question to solve for the other 2 variables. I'll be using the same variables from the previous question so we can confirm our answers when we're done. If you already know the kinetic energy and the mass, you can determine the speed by rearranging the equation like so. First, we multiply the mass by 0.5, so we have this. Then, throw the sum you just calculated to the other side of the equal sign, like so. Then, divide the energy by the mass. This gives you a sum of 151.29. Now that equals your speed squared. Now you have to square root this in order to get the speed. This will give us an answer of 12.3. We round to 12, so it matches our significant digits. This matches the speed given to us in the original question, so we did this correctly. Now, this might sound like a lot of work, but with practice it becomes super simple. You have to practice! We can also calculate the mass of an object if we know both the speed and the energy associated with that object. We rearrange the original formula like so. First, we square our velocity, so that turns it into 151.29. Then we throw over that 151.29 past the equal sign and divide the energy by it. So that equals 5,975.955 divided by 151.29. This will give us an answer of 39.5. Then we move over the 1/2 past the equal sign and divide the 39.5 by it. This gives us an answer of 75 kilograms. Does that sound familiar? Right, because it does match the mass given to us in our original question, so we know it's correct. Let's change gears a bit though and look at mechanical energy. Now, what is mechanical energy, you ask? Good question. Well, when energy is transferred to an object, it can cause a change in both kinetic and potential energy simultaneously. A ball thrown upward has kinetic energy because of its motion, and it also has potential energy because of its position relative to the ground. Since kinetic and potential energy are so closely related in so many situations involving energy transfer, they are combined as a general type of energy called mechanical energy. Mechanical energy is defined as the energy due to motion and the position of an object. Since an object can have both kinetic and potential energy at the same instant, mechanical energy can be calculated using the following formula. Mechanical energy equals kinetic energy plus potential energy. For example, let's say you threw a 0.300 kilogram baseball in a straight line through the air at a height of 2.50 meters above the ground. So you threw it at a speed of 20 meters per second. How do we calculate the total mechanical energy of the baseball? Well, to solve this, we basically combine the two formulas we just learned. First, we calculate the kinetic energy using the formula we just learned. Then we calculate the gravitational potential energy using the formula we learned at the start of the video. After that, we simply add up the sum to get the final amount of mechanical energy. It's crazy! That's crazy! In this case, the ball's kinetic energy would be half times mass times speed squared. So half times 0.3 times 20 squared. This would equal 60.0 joules. Easy enough. Then we calculate the ball's gravitational potential energy. And we do this by going mass times the acceleration of gravity times the height of the object. So 0.3 times 9.81 meters per second squared times 2.5 meters. This would equal 7.36 joules. We add up the two sums, giving us 67.4 joules. Remember, we rounded to 3 significant digits there. Now, if you're like me, you might be wondering why all this math works. Who came up with it? Simply put, it works because it follows certain rules or laws that dictate how energy and matter interact with each other. These laws are what we refer to as the laws of thermodynamics. The first law of thermodynamics is that energy cannot be created or destroyed. It can only change forms. Think back to chemistry and balancing equations. You need to balance all the elements because you never destroy any matter when you're doing a chemical reaction. You simply rearrange it. It's like the universe is a giant Lego set. You can build something, break it, and make something entirely new, but you are using the same pieces all the time, not adding or destroying any of them. This means that total energy input always equals total energy output. The second law of thermodynamics states that some energy is always converted into heat, and that heat always flows from a hotter body to a colder body. Think of letting the heat out of your house in winter when you open the door. This means that work input is always greater than the work output. Think of a light bulb. The vast majority of energy you put into it becomes heat rather than light, which is annoying. The work it takes to power the light bulb is far greater than the work that's actually being done to light it up. It's called efficiency. So that's all for this week's lesson. I hope everyone learned something new and interesting today. If you did find something particularly fascinating, try to teach it to someone else, whether it's your friends, parents, brothers, or sisters, or even your cat. Explaining something with confidence to someone else, even if it's fake confidence, helps you retain the information a lot more. Basically, the best way to learn something is to teach it to someone else. If you like this video, please hit that like button and subscribe to the channel. It really does help a lot and assures that you are notified every time I upload a new video. If you know someone that would like this video, feel free to share it. And if you want to continue your scientific journey, check out my other videos linked right here. Have a great day, everyone. See ya.